If every clock went dark right now, how would we still feel time? If light near its own speed makes time slow down, what does that mean for us? Does what passes really pass? Or are we sliding across a fixed map of past and future? Today we're talking about something that's with us every moment, yet slips from definition whenever we grab it. Time. Not a dry word in physics books, not just moving hands, but a story humans built to coordinate, survive, and explore, and later found it both a cage and a key. To start, let's keep a simple, practical definition. Time is the measuring of change. If nothing changes, before and after lose meaning. But that simple line gets messy in the real world. We sensed its importance the day we wanted to make appointments, organize farming, land ships safely, and later run trains on a single track without a crash. Let's step back, with dates and places, to see how this tale formed and why it still unfolds. Let's return to 45 BCE Rome. Julius Caesar introduced the Julian calendar to make the year 365 days with one extra day every 4 years. It stopped the seasons from drifting, but it wasn't exact, and errors piled up over centuries. Jump to October 5th, 1582, Rome under Pope Gregory XIII. To realign the calendar with the sky, 10 days were deleted and people went to sleep after October 4th and woke up on October 15th. However, not every country switched at once, and it took centuries for the world to mostly align on the Gregorian calendar. Meanwhile, in Egypt and the East, sundials and water clocks turned moving shadows and flowing water into the first minutes. But the story didn't end there. Urban life and trade demanded sharper precision. Enter the 13th century, Europe. Mechanical tower clocks without minute and second hands rang out market hours and prayer time. In 1656, The Hague, Christian Huygens built the pendulum clock and made a leap. Eras dropped from minutes per day to seconds per day. That meant traders, sailors, and craftsmen could finally see time instead of just guessing it. In 1714, London. Longitude at sea was killing people because no one knew exactly where they were. John Harrison's marine chronometer H4 fixed it, and with a reliable clock on the ocean, longitude became calculable. The result was saved lives and safer trade, but the price was a tighter bond between humans and the clock. October 20th, 1884, Washington, D.C. The International Meridian Conference named Greenwich as the zero of longitude in the world's time reference. With fast railroads, local city times no longer worked. Rails needed to know exactly when and where a train would pass. This brought order to the world and highlighted our differences. From those days to now, time became both a tool for cooperation and a metric for pressure. Now jump to the early 20th century when the meaning of time flipped. In 1905, Albert Einstein, a patent clerk, published Special Relativity and said, Newton's absolute time doesn't exist. Two observers moving at different speeds measure time differently. A moving clock ticks slower. 10 years later, 1915, he showed with general relativity that gravity bends the very fabric of space-time. A clock on a mountain ticks faster than one at sea level because gravity is weaker. These weren't just pretty words, they were testable. In 1971, the Haffel-Keating experiment flew atomic clocks east and west and found differences of tens to hundreds of nanoseconds. Philosophy turned into numbers, yet our reliance on exact time was only beginning. In 1949, the first ammonia-based atomic clock was built in the U.S. In 1955, Louis Essen and Jack Perry built a practical cesium clock in the UK. In 1967, the second moved from Earth's spin to 9,631,570 oscillations of the cesium-133 hyperfine transition. That shift freed us from Earth's wobble and tied the second to an atomic, repeatable process. In 1972, Coordinated Universal Time, UTC, began with leap seconds to keep pace with the solar day. Since then, leap seconds have been inserted more than 20 times to offset Earth's irregular slowing. Meanwhile, to feel it in our pocket, just look at your phone. GPS would run ahead of Earth by about 38 microseconds per day without relativity corrections. That's roughly plus 45 microseconds from weaker gravity and 7 microseconds from speed. Skip those fixes and your location would drift by about 10 kilometers per day, making navigation useless. That's one data point showing time is not just philosophy for today's tech, it's infrastructure. Let's add a few more numbers to sharpen the picture. We estimate the universe at about 13.8 billion years old, and yet the smallest tick physics recognizes, the Planck time. Earth's sidereal day, one spin relative to distant stars, is 23 hours, 56 minutes, and 4 seconds, not exactly 24 hours. Our body clock averages a bit over 24 hours, about 24.2, which is why without morning light we drift later and later. And our reaction time is on the order of 0.2 of a second, about 200 milliseconds from seeing to doing. Back to the evolving idea of time and how its meanings changed. In Greek philosophy, Aristotle called time the number of motion, the counting of change. Centuries later, Augustine confessed, "If no one asks me, I know what time is. If I try to explain, I do not." Newton in 1687 said time is absolute, uniform, and independent, flowing by itself. Leibniz pushed back, saying time is just relations among events, not a container. Still, in the Einsteinian 20th century, two strong views took shape. Presentism says only the present truly exists, with past and future unreal. Eternalism, or the block universe, says all times exist at once, and we're like a light moving across a film reel. Meanwhile, physics gives us an arrow of time pointing from past to future. Not because the fundamental equations demand it, they're often reversible, but because of entropy. The second law says disorder in a closed system tends to increase, like milk mixing evenly into coffee and never separating on its own. That entropy growth anchors our experience of flow, even if the equations look fine played backward. But the story didn't stop there, because at quantum scales, time itself wobbles. Carlo Rovelli argues time isn't fundamental and that relations between systems give it meaning. Julian Barber suggests the universe is a timeless set of configurations, and the feeling of flow is a link in our memories. The Wheeler-DeWitt equation in quantum gravity even seems to remove time, making the entire universe static. Yet we wake up, drink coffee, and go to work. So what does any of this do for our lives? It's simple. The algorithms recommending videos optimize for watch time. The product is our attention, measured in minutes of our lives. Financial systems sync to atomic clocks, so a millisecond earlier or later doesn't swing millions. Remote teams hop from local time to UTC and back again so humans can actually coordinate. With scheduling, we gain productivity. With time pressure, we burn out. Two edges of the same blade. Before industrialization, church bells and the sun ran life. After factories, we got shifts and coffee breaks. Rails standardized time to stop crashes, which was great. On one hand, without exact time, global flights, the internet, and GPS would crumble. On the other, once everything got measured by seconds, we felt that losing a second meant losing life. Today, optical clocks in labs reach fractional precision near 10 to the minus 18, run once since the Big Bang, and it might drift by about a second. At that precision, we can measure time passing differently over a few meters of altitude. With it, we can map Earth's gravity and push navigation to new trust levels. And yet, our opening question remains: does time exist, or are we numbering change and calling it time? If the block universe is right, the future already is. We just haven't turned that page yet. If presentism is right, the past is truly gone and the future not yet real. Only now exists. Take some quantum views seriously, and time may be a useful tool rather than a thing in itself. Still, our experience is personal. An hour with someone we love feels like 5 minutes. 5 minutes waiting for test results feel like an hour. That elasticity is tied to brain, attention, and emotion. So physical time and psychological time run side by side on 2 layers. Now back to today, to you and us. That's not just Pomodoro. It's a negotiation with the brain to bend our sense of time in our favor. When we cue our body clocks with morning light, we sleep and learn better because we're syncing to that 24.2-hour rhythm. When we stay up late, we send the wrong signal and slow down the next day. And now the future. One where optical clocks land on the moon to enable lunar and Martian navigation. One where networks of ultra-precise clocks reveal tiny gravitational ripples and hint at dark matter. One where we might retire the leap second so the internet can breathe. And one where new equations demote time from the fundamentals and show what we call flow is a web of relations. And one where new equations demote time from the fundamentals and show what we call flow is a web of relations. Where do we stand? Right on the edge, with clocks more precise than ever and a human sense of time that stays elastic. With a calendar that coordinates us and can wear us down. With science saying time is relative and a heart insisting now is everything. To close, let's leave one big question open. If physics someday shows time, as we know it, doesn't truly exist, how will we redesign our lives? Do we rewrite schedules, plans, and dreams, or just rename time and carry on? Tell us what you think. How do you handle time, and what does time do to you? Since you stayed with this story to the end, should our next episode dive into psychological time, or go deeper into optical clocks and the future of space navigation? We can't wait to continue together.